So today we are going to learn about the regularization. So what is regularization? Why is it necessary? And where where we can apply regularization method. So regularization is the method uh, by we can minimize our overfitting of model. So first of all, we have to learn about the why overfitting occurs in our model. So when we are going to train our model, there might be in data some noise has trained with our uh, in training phase of our model, and it might be also happens some irrelevant features has been included in training phase, and that will occur our overfitting of models. So how can I resolve it, and what is the consequences if this kind of things happen? So when our model get overfitted, so there might be that model would be uh, they are not perform very well in testing phase, but when we are going to training phase, there seems like to be a very uh, best model, like to be a very good accuracy, but when we are going to test it, it will perform very worst way. So that kind of scenario will happens. So we want uh, want to be our model would be a better one when, but when we are going to apply in a real kind of data, that would be perform very worst. So we have to our model should be very stabilized way, so we can use in a production way. So that time only a reliable model is uh, used in a production, just because of they are very realistic for the testing or trading, because of they have accurate accuracy giving there. So that's why we use there. So lasso regularization has a two method. First one is lasso, that is also known as L1 regularization, and second one is a RIS, that is L2 regularization known as. So what about the lasso regularization? So lasso regularization stands for, it has a full form: uh, list absolute shrinkage, and selection operator. So by this name of this regularization method, it giving some information. So let's understand about the one by one each sentence, each word, and it will reveal the definition of lasso. So lasso, it is a list absolute uh, shrinkage and selection operator. So whenever we are going to apply our lasso regularization, there might be any other feature get zero effect in our model training. So it means our feature has shrinked, and when our relevant features are came in there, that feature has to be selected for the training purpose. So lasso, it is the yi minus y whole f. It has a cost function, that is y minus yi whole square plus lambda m square. So what is the here is n, uh, y minus y whole square is also known as error here. Whenever our model going to train there is some error occur in that time. So our prediction is something, but actual value is different, and that difference is called to be error there. And here is lambda into m square, where is the lambda is the penalty, that is also called the regularization coefficient, and m is the it is it is known as a slope, or you can say here is the gradient. So whenever we are going to apply our lasso regularization in our model, so uh, they can depreciate our effect in our model. So whichever our feature is not more relevant, they can devaluate that effect, and that kind of way our model get fitting with our whatever trend model we have, and they are coinciding with our testing and training phase. So, and other one is raise. So why is it necessary to be a raise method uh, while we have also lasso? So uh, it is it has a cost function like y minus yi whole square plus lambda into, sorry, we have there is some mistake here. In a lasso there is a modulus of m, but in a ridge there is a square of m square. So why is it necessary to came here a res method for regularization? So sometimes our model, every feature has uh, relevant features. So we do not want to be that feature has to be extinct. So how is it possible to that model is not accurate there? So there might be possibility to be some noise has been trained with our model. So we need to be that noise to be removed. So in that way res model we have panelized there, and they get minimize the effect of noise in model training, and they won't be make you zero effect in your model, but they will minimize minimize the effect there, and they will never lose never lose your potential of your features on your training model. So that kind of raise method uh, do their regularization, and they will make you fitter for production phase, production level your model. So that's the way we have to deal with the regularization, and that is the advantage. So we minimize overfitting in our training phase in model. So that's all today for about the regularization.